Welcome, y'all. We're here to learn about areas of parallelograms and triangles. Let's talk about that. So let's kind of break down the individual parts of it. So as a parallelogram says, it's a quadrilateral with both pairs of opposite sides. Now, as you can see, we have these two opposite and these two opposite. They're parallel. Now, your base and height are the things you need to know as far as your parallelogram to find its area. Now, the bases can either be the longer side or the shorter side, depending on how it's laid out. So, for example, here, the base is right there and right there. There will be two of them, but we only need one. The height has to be perpendicular, to your bases. Now, as far as the height goes, Philip, excuse that, Philip's over here trying to cheat. As far as the height goes, the height has to be perpendicular. So for example, here, there's no way to make a perpendicular line on the inside. So you can extend one of the bases out to make a perpendicular between both bases with the height. Now, according to this postulate here, the area addition postulate, sometimes we get a weird shape like this. We got this particular shape right here that as one whole shape, there's no way to figure that out. But if we break it down to smaller individual shapes that we do know, a bunch of parallelograms, we can figure that out. So we find the area of each one individually. 1 times 1 gives us 1. 1 times 2, we got 2. 2, and then this side should be 2. Since this is 1, this side right here is 1. As far as this one's 1, so that gives us 2. 2 times 2, we get 4. 2 times 2, we get 4. This over here should be 3 times 3, 3 by 3. If that's 2, this side right here is 2 plus the 1 gives us 3. And if that's 1, that's 1, this side right here is 2, making this whole thing 3. Gives us 3 by 3, gives us 9. And then this big one, since, and this is where we kind of have struggle with. If this is 1 by 1, that means this section right here is 1. If the whole thing is 11, that means the rest of this will be 10. 10 times 2, 20. As we add these up, 20 plus 9 plus 1 is 30, plus 2 plus 4 is 36, plus 4 is 40. 40 units square. So, according to the area of a parallelogram, you take base times height, and that's it. So, for example, this is a stereotypical parallelogram. This is a rectangle, and this is a square. All right, base times height. This is 6. This is also 6. Our height is 4, so 6 times 4 is 24. Here we got 9 times 5, 45, and then 5 times 5 is 25. Pretty simple. But sometimes we might be left with a problem like this, where we do not have a height. Now, a common mistake is that we try to make this side the height. We cannot do that. We have to find the perpendicular distance between the two bases. But this is a special right triangle. That's a right angle on this side. That's a right angle on this side, making this a 30, 60, 90. And if we remember our 30, 60, 90 degree triangles, 60, the value of the smallest side, which is across from the x, across from the 30 is x. The hypotenuse is twice that length, so this is 2x. And our long side is radical 3 times more, makes it x radical 3. So if this is our hypotenuse, to go backwards to our small side, we divide by 2, making this 5. And to get our hypotenuse, we will multiply by radical 3. Give us 5 radical 3. Now, we're going to take our base times our height. So 15 times 5 radical 3. We multiply those two. We end up getting 75 radical 3. Unless told elsewise, we're going to leave it like that, 75 radical 3. So when we're looking at this, the perimeter of a square is 28 units. What is the area? So it's a square. That means every side is the same. So to find the length of one side, we take just 28 divided by 4. We get 7, making each side 7, 7, 7, and 7. To find the area, we'll just multiply base times height, which is 7 times 7, giving us 49 units squared. Talk about triangles now. So triangles, very similar to a parallelogram, is a base times a height, but we're going to divide this by 2. Now, the height also has to be perpendicular. For example, here, the height will always come across from the base, for the angle across from the base, making this a right angle. So base times height. Sometimes the height, similar to a parallelogram, will exist outside. This is the height we'll use, but we'll still only use this section as the base. We will not include this at all. So, for example here, find the perimeter and area. So the area will be the easier one. So area, again, is base times height divided by 2. The base, of course, is 16 right here. And here's the perpendicular connection. So this will be our height. So we're looking at 19 times 30 divided by 2. So we take 19 times 30. We get 570. So we get this equals 570 over 2. So then we divide that by 2. We get 285 units square. Now for perimeter is equal to the sum of 3 sides. So in our triangle here, we have 2 of the 3 sides. We have this side, which is 19. This long side, which is 41. We are missing this side, the third side of our triangle. So what we're going to do is we're going to look at this right triangle that's formed with these extended sides and see, hey, I have 2 of the 3 sides. This is a right triangle, so this we consider the hypotenuse. We can do our Pythagorean theorem, where 27 will be our A and 30 will be our B, and X will be our C. So we'll do 27 squared plus 30 squared equals X squared in this case. So we take 27 squared, we get 729. Take 30 squared, we get 900. That equals our X squared. We add those up, we get 1,629 equals X squared. And to get rid of our X squared, we need to square root the 1629. So we square root both sides. X equals 40.36. We're going to carry 2 decimal numbers. So making this 40.36. And then we just add all 3 up. We do that. So 19 plus 41 plus the 40.36. Get 100.36 units. This is just perimeter. We just do units, no unit square. And that is your parallelograms and triangles.